Hi everyone. Here I'm going to discuss about how to revise your haloalkanes and haloarenes in a less time or in an easy way or by taking less time. So haloalkanes and haloarenes. After completing studying this chapter, how to revise it, let me show you. So haloalkanes, haloarenes. So now let us try to remember what are the reactions, what are the reagents that is involved. Okay, what are the reagents that is involved in these reactions? Now, as we are studying about the haloalkanes, definitely we are going to know about this, about the formula of this compound. That is, halo means halo, alkane means R. So alkyl halide or haloalkane. So we know this. So we are going to treat with this compound. We are going to treat with this alkyl halide. Okay, we are going to just alkyl halide with many reagents, with different varieties of the reagent, and see what is the product, what product will be formed. Right. So in this chapters, the most important reactions that we have learned or that you have learned, that is RxNA. So sodium is a metal. So in these chapters we will deal with the two metal reactions, that is with the sodium and magnesium. So I have taken alkyl halide. I have treated with sodium. What will be the formation of the product? Let us see. So this is one of our reagent that is involved in this chapter, that is included in this chapter. So sodium and magnesium only these are the two metals in this chapter. So whenever once we see sodium, we have to keep in our mind that sodium, the reaction that is involved with the sodium metal is Wurtz reaction. So this is Wurtz reaction. So this is Wurtz reaction, and we should know what is the aim of the Wurtz reaction. What is it? What product does it form? Does it form? Okay, so we should learn in this way that in the Wurtz reactions we are going to form hydrocarbon that is also symmetrical hydrocarbon. That means we can divide it into two equal halves. And also we have to know that Wurtz reaction always involves sodium metal with alkyl halide, and the product form is twice that of the starting material. We have started with 1R. In the product side we will get 2R. It will get doubled. Okay, so what is left out? Na. So Na, then Cl. So there are 2R, so twice, then okay, then twice, okay, then twice here. So this is Wurtz reactions. So Wurtz reactions deals with the haloalkanes, not haloarenes, with haloalkanes, that is chain halide treated with sodium, then we will form this product. So in these reactions we got the reagent that is list it out. Okay, it will take a little bit longer time for this to explain. So we got sodium. Okay, number one, we got sodium. Now let us go to the other reaction. See, by knowing these reactions you can do numbers of reaction, but just by changing this R with the ethyl, methyl, isopropyl, anything here with the chlorine, bromine. Okay, then let us go to the other one, alkyl halide. Okay, this alkyl halide, we have only two metals, as I have mentioned. There is magnesium. So let us see what does it forms. Here it forms symmetrical, but what does it differ here? Okay, so this is very simple. We will just form RMgX, which is called Grignard reagent. This is called Grignard reagent. So in the Grignard reagent, there is R, there is M and X. What changes has brought here? This magnesium has just inserted in between. So this is somewhat type of insertion reactions. So this is also somewhat type of like addition, right? But it's not actually addition. So we have formed Grignard reagent. Okay, so from chapter C, we have two metal, one sodium, that is the Wurtz reaction, another magnesium, that is formation of the Grignard reagent. So we have another reagent that is magnesium. So you learn in this way. Again, this Grignard reagent. See, this Grignard reagent being very, it should be always in dry condition. So dry ether. So it will be free from the moisture. So this Grignard reagent is very reactive. So in the presence of any proton source, that means H plus source like H2 or NH3, you will get a proton from here. It will break and it will form hydrocarbon. So from here one proton we will get, it will react with R, so RH. Okay, this R is minus, negative, acting as negative. This is 2 plus. So from here one proton we will get, it reacts to form hydrocarbon. Then remaining Mg has remained. Then from water OH has remained, H has we have already added here. So OH has remained, so we will write in this form. See, now we got Grignard reagent. Grignard reagent being very active, we form this compound. So Grignard reagent is very helpful in the formation of what? In the formation of hydrocarbons. Okay. So this also hydrocarbon, this also hydrocarbon, this also metal, this is also metal. So in these chapters we have two metal reactions with the halides, and that is also, and the product is also very much, see, the product is also very much similar. If we extend your Grignard reagent, it's also hydrocarbon, this also hydrocarbon, but here to be very specific, this is symmetrical hydrocarbons. Okay. So we got two reagents now. Now let me take alcohol. Okay, let me take alcohol. See, I have taken alcohol. So with this alcohol, with this alcohol I can write many reactions like SOCl2 in the presence of base pyridine. Okay, Py, and see, I can take with PCl3, PCl5, and we have red phosphorus with any, okay, Cl2, let me write Cl2. See, I can just treat your alcohol with this, alcohol with this, alcohol with this, and the product will also be similar. See, R, this OH will be Cl, from here is Cl. So R, Cl, R, Cl, R, Cl. I will not still write the side product. Okay, I will not still write the side product, but see, R, everything remains same, the products are same, the starting material is same, the starting compound is same, the reactant is same, only the reagents are different, but they are having the same source. That means they are giving the chlorine, they supply chlorine, right? The side product you have to learn it, SO2, or there is also some way how to learn it. Okay, HCl, CrCl, Cl, O, and with this SO, O, SO2, H, and Cl, HCl, plus 3, PCl3, RCl, just start with 3, this 3 you just start, H3, H3PO3, plus PCl5, POCl3, plus HCl. Okay, there is no side product for here. So see, we have so these are the reagents. So what are the other reagents? See, we have SOCl2, we have PCl5, we have PCl3, we have red phosphorus with any X2, okay, or Cl2, Br2. Okay, so this is the these are the reactions that I have collected. You should collect in this way to remember the reactions properly. Okay, now let us again go for the, when we study the reactions, we always think about addition reactions, substitution reactions, elimination reactions. These things are very common in the reactions, right? So when I say addition reactions, always addition, we are going to add something, so there should be enough space to add. So CH2, whenever we talk about addition reactions, or whenever we see think about addition reactions, we should always treat with the multiple bond. So once we see the multiple bond in your starting compound, then remember that this will always undergo addition reaction. Okay, so see this HCl, see the negative part, chlorine is your negative part, and this negative part will go to the carbon atom of the double bond containing less hydrogen. So this, see how to write, CH2, CH2, CH, CH, don't change anything, double bond change into single bond, done. Then as pi bond breaks, it will form one bond here, and the negative part will go to carbon atom of double bond containing less hydrogen. So this is your answer. So this is called addition reactions. We have Markovnikov rule. This is your Markovnikov rule. Okay, Markovnikov rule. We have also another see, we have 6, 7, we have addition reaction. We have addition reactions. Now let's go to the other one, that is anti-Markovnikov or crush effect. Okay, Markovnikov, Markovnikov reaction. See, in this case, see, these are anti-Markovnikovs is also addition reactions, but it is against the Markovnikov. Okay, so how to differentiate? This is CH3. Okay, there is mistake here, CH3. So how to differentiate between Markovnikovs and anti-Markovnikovs is also easy. CHCl. In case of anti-Markovnikovs, always there will be peracid or there will be peroxide, okay, peroxide, hydrogen peroxide, perbenzoic acid. So see, the product will be see, multiple bond will change into single bond, no doubt, okay. But now the addition will be just opposite. Cl will be here, that means negative part of the reagent will go to the carbon atom of the double bond containing more number of hydrogen, okay. So this Markovnikovs. How to differentiate between this and this? There will be always peracid or peroxide in case of anti-Markovnikovs rule. So we have addition reactions, we have Markovnikovs and anti-Markovnikovs rule. Now as we know about addition, we should also remember about elimination, right? We should also remember about elimination. Okay, let's continue here. Elimination. So when we say eliminations, we are going to eliminate some of the groups, some of the elements from here. So whenever we think about elimination, so there will be always a leaving group which can be Br or which can be Cl, mostly halogens group, okay, or a negative group. So we will always treat with alkali hydroxide in, that is also in alcoholic condition, okay. So now we should always focus with Br carbon. So Br carbon, this is your alpha carbon, this is your, next to that is your beta carbon, okay. So we are going to eliminate some of the group from the alpha and beta. Let me write the product here. So CH3 will be safe there, okay. We are going to CH2, okay. We are going to remove one of the beta hydrogen and the good leaving group, that is your Br, okay. This from here Br has gone out, from beta hydrogen will go out, so plus HBr has gone out. So this is has gone out from where? From alpha Br and from beta. In between that there will be multiple bond. So in elimination reaction there will be always removing of the groups. By removing the group there will be one extra bond will be added here, okay, extra bond will be formed here. So you see, in addition double bond gets into single bond. In elimination single bond, all this single bond gets into double bond. So they are just opposite, they are just reverse to each other. So we know elimination reactions. Now we'll have another reaction, that is substitution reactions. Okay, substitution reaction. So when we say substitution reactions, let us take CH3, CH2, let us take alkyl halide, okay. So I will take same elimination and alcoholic alkali hydroxide, it can be sodium hydroxide, potassium hydroxide, but here the condition should be aqueous, okay. So the product will be substitution, means the negative group will be replaced by another negative. So CH2OH, and what has remained? KCl, okay. So this is substitution reaction. In case of substitution, the condition will be in the medium will be in aqueous, and here it will be, the medium will be in the alcoholic. So this is substitution reactions, okay. Now let us go to the name reactions like phytic reactions. So phytic, when we say phytic reactions, remember the Wurtz reaction. Wurtz reaction includes what? Sodium. This also will include sodium. Phytic reactions, in the Wurtz reaction it was with the straight alkyl halide, but this will be with the ring halide, okay. So ring halide, okay, we have taken one, it will just get doubled, okay. So that is the Wurtz reactions, same to that, okay. Okay, so this Wurtz reaction. Again we have another reaction, that is Wurtz phytic reaction, okay. So in the Wurtz phytic, see, Wurtz means with a straight alkyl halide, and that means alkyl halide, open alkyl halide, okay. Then phytic means with the ring halide, so we will take ring halide, okay. So we have treated, we will just take this R group, we will just connect it. Connection should be always where the Cl bond has connected, there will be always CH3 plus NaCl Okay, so what's reaction? We have another that is Federal Craft, FRIE, the Federal Craft, alkylation reaction. Okay, Federal Craft alkylation reaction. So this Federal Craft alkylation means, see, from the name itself we can get lots of information. Alkyl means alkyl group. Okay, R group. Addition means addition, we are going to add alkyl group. So let us make alkyl. Alkyl cannot be only single alkyl, there should be a counterpart, so Cl plus. And now again this reaction is easy to remember because this is always in case of aryl. Okay, this is always in case of aryl halide. Okay, single bond. Okay. Yeah. Now the reagent should be always in anhydrous. It should be anhydrous, AlCl3, that means Lewis acid. Okay, so see, the Cl will remain undisturbed. Only this alkyl group alkylation, so alkyl will be in the alkyl will be in the 1 2 position, this 2 position, or we can say in the ortho position. This is called your ortho. 1 2, this 2 position is called your ortho. This CH3 plus this, again we have another product Cl in the 1/4 position, that is your para position. This is your para, this ortho position. So let me do with the last one, that is Federal Craft acylation. So student must know what is acyl group, what is alkyl group. You are not clear with the alkyl acyl, you can't do the reaction. Okay, so Cl plus acyl means RCO. This R can be anything, that means any alkyl group. Cl, same, anhydrous, AlCl3. Okay, let me, so the product will be same, the Cl will remain undisturbed. Okay, and this here, this part will go out, and this carbon is positive. Okay, remember this carbon is positive, so you will always connect with the positive carbon, COR plus. Another product is what? Okay, it's not possible to write here. I'll write here in a very COCH3 Cl. Okay, right, we should write very clearly, the bonding should be very clear. I have no space and up, there is one. So this is your Federal Craft acylation. See, so after learning your chapters, after practicing your chapter, just take a clean page and try to collect all the reagents that you have done. So and see what this reagent should be treated with what, or this reagent forms what. Okay, should be treated with what, and what is the aim of this reagent, what does it gives. Okay, so you should learn in this way to make it easy. So this is the way how to revise the chemical reaction. First and foremost thing is that clear with the all the IUPAC nomenclature of the haloalkanes. Okay, all the functional groups. Okay, if you're not clear it, then the reactions becomes easy. Otherwise, even though you practice without knowing the IUPAC name, you will forget. Okay,